Welcome to another episode of Cutting Edge Health. And today we are talking about an article that was just published in the New York Times on May 22nd, which showed an interesting discovery that's put forth. And basically, it's a scientist finds signals for chronic pain, and we're going to explain to you why this is a big deal. If we haven't met, I'm Dr. Orlando Landrum. I'm an interventional spine, interventional orthopedist, as well as a physician that helps with interventional psychiatry and helps people be able to figure out how to punch pain in the face, whether it's physical or whether it's mental, and get back to leading the life that you deserve. So interestingly enough, there was an article that was present on the New York Times page that was published on May 22nd, 2023. So just recently, that looked at how to be able to evaluate chronic pain specifically present in the brain. And for many people, if you've been watching our channel, you know that's something that we've talked about for quite some time, right? And so we've had discussions about that. But this particular article looked at something a little bit more involved. And so in essence, what they did is they found signals of the chronic pain that were located in two different areas, specifically the two different areas where they had chronic pain patients basically rate their pain scale on a 0 to 10 scale, as we very well know. And they looked at the fluctuations of the pain severity, but specifically it was a researcher that published a study, and that study is the following right here real quick. That was in Nature Neuroscience. And what they did is they only looked at about 4 people or so, but they're going to do more than that. And what they did was pretty aggressive in some ways. They did a trial that had implantable leads into the head that looked at how people dealt with pain and how they were able to measure it directly. So they're going to be moving from a larger study of 4 people to 6, and then going on to 20 to 30. The researcher is a researcher that's present at University of California at San Francisco, and they found some pretty interesting things. So when we look at the actual paper, which is what we always do and take a look at the science, this is the paper itself. So as it reads, it's the first in actual humans prediction of chronic pain state using intracranial neural biomarkers. So I know that's quite the mouthful, a lot to be said, but we're going to explain it, what that means, and we're going to get you understanding exactly how to be able to kind of understand what is entailed. So that study, the thing that makes it unique is historically when we look at brain scans, and we've talked about this in numerous different videos before, they normally look at scans that are non-invasive, like a quantitative EEG or measures like functional MRI or PET scans. But this involved actually implanting electrodes directly into the brain and then taking recordings as they went about their daily lives. And what they found was some interesting things. So the recording, if you're kind of interested in what the picture looks like, and picture from New York Times shows you the following, where they have these leads that are in place in the brain, and you can see the battery and the generators that are present down here, right? So they had the electrodes implanted, 4 different participants, and they had the severity of pain evaluated. And they provided 2 to somewhere around 8 of these pain reports a day for 3 to 6 consecutive months. And they would log what their pain was, and each participant would push a button to cue the implanted electrodes to take a 30-second snapshot of their brain activity. So while they're feeling the pain, basically they're able to kind of see what is the brain doing, what's the brain waves that they're experiencing. And they took that data and they then imported it into a machine algorithm that evaluated what were the consistent patterns of the brain. And so they're going to start getting a little bit more technical. We're going to talk about different parts of the brain, which interestingly enough have similarities between both pain as well as mood, specifically treatment-resistant depression that sometimes is very difficult to be able to improve with traditional medication alone. There's some overlap, and we're going to talk about that in a sec. But at the end of the day, what they found is that there was activity of something that's called the OFC, which we're going to explain, and not the ACC. And so what the heck are those? So this is from that component. So the ACC is the anterior cingulate, And then the OFC is the orbital frontal cortex. And so the ACC is an area that has been looked at for a number of different things, but specifically chronic pain. And it's been studied over and over and over again. But the OFC for chronic pain is kind of unique. They found that when you take a look at this picture, and the picture shows the red dots of what's the degree of amplitude, and referring to when they measured how active was it. So the OFC in this picture is yellow, while the ACC is purple. And although you can see red dots in both, what they saw is that it was more prevalent for different patients to have this OFC distribution. And this is kind of important and a number of different reasons. But basically what they kind of summarize in this component is that brain waves are generated by either region could be used as a metric or a biomarker of the patient's severity. So a way to be able to assess it. But what they really kind of came to, and our main researcher stated that we saw that each patient's biomarker was actually like a unique fingerprint. So in essence, it's different from patient to patient. But why this might be of value is there might be a way to be able to potentially intervene upon it, or as one article kind of described, could we potentially short circuit that pain, mainly by using a non-invasive methodology to target the brain wave as opposed to targeting the site itself. And we've talked about that with TMS before, but not with the uniqueness of how this article specifically references this other area of treatment. And interestingly enough, there's also been a parallel that has happened with the treatment of depression. So there's a different paper out there, which has been out for quite some time, about 2018 or so, that looked at the orbital frontal cortex, same area, for major depression. And historically, when we're treating depression using the aspect of TMS, we're using the area that's the prefrontal cortex, which is a different area completely. But what they've seen is that there are some patients who are not quite as responsive. And so by treating the orbital frontal cortex, you may get a better response. And so this particular paper basically was able to see in a completely different area, not the same paper that was present in the New York Times, that it looked at treatment for a major depressive disorder, and it was able to see that that area provided value. So what is that area? What does it look like? Well, it looks like the following. So this is a TMS treatment for depression, but it's centered in and around this region. If you kind of give the speculation of like, where would you find this on someone? So it's a little bit over the eye, a little bit off to the side, and that's a way to essentially be able to treat that area in that region. So what they found is that there's a certain pathway, and it's interesting that they see this for pain, but basically there's a pathway that's called a non-reward pathway, who in this context for mood has a self-perpetuating hyperactivity that can be central to the mechanisms of illness, specifically for major depressive disorder. Now, the researchers who did this at UCSF that's looking at pain didn't say that it's the same area. They didn't say that it's a self-perpetuating mechanism or pathway that's present, but maybe there's some similarities that's present there. And potentially the interesting piece is, can we be able to devise therapies that are not dependent upon medications and not dependent upon an actual physical intervention? Because now having been able to really clearly know, not just make guesses about, well, the QEEG or EEG shows this or functional MRI shows this, but by knowing it definitively that that wave changes and can change based off of the region as well as the severity of the pain, that we might be able to say, how can we use this in order to improve pain overall? So interesting article that is pushing medicine forward with potential treatment options that can be able to help people punch pain in the face and get back to leading the life they deserve. If you enjoyed this video, please hit the like button. If things that are pushing the envelope of treatment of how to be able to hopefully get improvement and beneficial outcomes without as many side effects and or potential issues are interesting to you, please leave a note. And if there are questions that you have, let us know so we can help you be able to figure out how to be able to improve your health, stop physical or mental pain, and how to be able to get back to leading the life that you deserve. Thank you so much and have a great day.